Hey, Mr. Albert here, and we're continuing probability discussion, and now we're going to talk about empirical, or sometimes called experimental probability. And I have here empirical probability is based on previously measured experiments. What I've got here, an example of this would be if you flipped a coin 10 times and it came up heads each time, then you may naturally think there's something off with this coin and assume that it's likely to come up heads the next time instead of the 50-50 chance with it having two sides. So empirical or experimental probability is known for looking at collected data or previous experiments, not the everything has a equal chance of happening. Okay. So the formula here, all the things look the same, so we're still using P of E for the probability of an experiment. But on the bottom here we have the number of trials or the number of times data was collected, as we'll see going forward. And on top of that we have the number of times the outcome that we're looking at occurred. Okay. So let's kind of see this in action down here with a couple of examples. So a sample of 500 active duty military showed that 82 of them suffered from post-traumatic stress disorder or PTSD. However, 95 of those studied reported they would be too embarrassed to seek mental health services. So we have some data collected here. Top the 500 people, 82 of them said they have PTSD, and 95 of them said that they would be embarrassed to ask for help. But question A here, based on this sample, if a soldier is chosen at random, what is the probability that she suffers from PTSD? So the reason this is empirical is if we were talking about classical, there's two options here. The person either has PTSD or does not. So that's basically two options, and if we treated them the same, it would be 50-50 or 0.5. But because we know that that's not true, and we have data up here supporting it, we're going to say the probability based off of what has been gathered is that the 82 out of the 500 may suffer from PTSD. I'm going to write these as decimals, or at least this one. If it comes out to be a scary decimal, I won't. But it comes out to be even. It's 0.164. So if you think back to percents, that's around 16%, but probability is not written as a percent. B, based on this sample, if a soldier is chosen at random, what's the probability that he or she would be willing to seek mental health services? So again, there's two options there. They either do or they don't. But based off of the data, they're not weighted equally. So we're talking about the probability of, let's just say, help. So there's still 500 we're looking at. Would seek. So up here they're saying that 95 would not. So we take those 95 away from the 500, and that means 405 would. So let's write that both ways. 405 over 500 looks like 81 out of 100, which if we turn it to a decimal would be 0.81. Okay, so make sure you understand that this up here said be too embarrassed, so that means those 95 would not. So I took those away from the 500 to demonstrate those that would. I think I have one more example here. Bobby is playing a board game. He has had 23 turns so far, and each time rolls a 4-colored die. Okay. So far he has landed on blue 8 times, red 4 times, yellow 11 times, and green 0 times. Okay. So maybe there's something wrong with this die. Maybe it's not weighted evenly, distributed evenly, or maybe it is. Maybe this is just the luck here. So using empirical probability, which means his previous rolls, was the probability Bobby will roll blue on his next turn. So we're doing the probability of blue, and he's had 23 shots at this. So he's rolled 23 times, and he has landed on blue 8 times. So based off of what's been collected, there's a likelihood of 8 out of 23 chances that he will land on blue again. Now that may be true, it may not. It's just based off of what's happened. If we did classical probability, so this is empirical. Oh, I'm going to ask that question down here. Yeah, but let's write it here. Let's make sure we're emphasizing empirical. But below it says using classical probability, what's the probability Bobby will roll blue on his next turn? Okay, so there we go back to how many choices are there? There's 4 colors and only one of them is blue. So very different outcomes here, depending on how we look at it. Okay, so keep in mind that empirical, if you're given data, can be very different than classical if you're just given options. And usually you kind of do one or the other without even thinking about it, just based off of what you're given. But sometimes it may be worth giving it a second look.